Look up at the night sky tonight, and you'll see it the moon, glowing softly, seemingly peaceful and unchanging. But behind that familiar face lies a world of secrets, anomalies, and unanswered questions that have puzzled scientists, astronomers, and even casual stargazers for centuries. Think you know everything about our closest celestial neighbor? Think again. The moon is far stranger than it appears, hiding mysteries that defy explanation, from bizarre structures on its surface to unexplained flashes of light, even whispers of something unnatural. For thousands of years, civilizations have worshipped the moon, feared it, and woven myths around its silver glow. Yet even now, in an age of advanced technology and lunar landings, it continues to surprise us. Why are there reports of strange, transient lights flickering in its craters? What causes the odd, geometric formations spotted in high-resolution images structures that look anything but random? And why did astronauts report hearing unexplained sounds on the far side, where no human should have been able to hear anything at all? These aren't just gaps in our knowledge, they're full-blown enigmas, clues that something far more mysterious is at play. That's exactly what we're diving into today, 25 of the moon's most baffling, spine-tingling mysteries. Some of these might sound like science fiction, but they're backed by real data, eyewitness accounts, and even declassified documents. Whether it's the unsettling case of the so-called lunar wave, the puzzling absence of expected impact craters in certain regions, or the controversial claims of ancient artificial structures hidden in plain sight, each one challenges what we think we know. So if you've ever gazed up at the moon and felt like there's more to the story, you're absolutely right. Strap in, because by the end of this journey, you'll never look at that glowing orb in the sky the same way again. The moon shouldn't exist, at least not the way we see it today. When you step back and look at the facts, our lunar companion defies everything we know about how celestial objects form. Take its size, for instance. The moon is a quarter the diameter of Earth, making it the largest natural satellite relative to its host planet in the entire solar system. Compare that to Mars' tiny moons, Phobos and Deimos, which are little more than captured asteroids. This alone raises a glaring question: how did something so massive end up orbiting us? Scientists have wrestled with this puzzle for decades, proposing three main theories, each with its own flaws. First, there's the capture theory, the idea that the moon was a rogue body snagged by Earth's gravity. But here's the problem: the moon's orbit is nearly circular, and its composition is eerily similar to Earth's crust. A captured object would likely have a more chaotic trajectory and a completely different chemical makeup. Then there's the co-formation theory, suggesting the moon and Earth condensed together from the same cosmic dust cloud. Yet, if that were true, why isn't the moon's core much larger, like Earth's? The most widely accepted explanation is the giant impact hypothesis, a cataclysmic collision between a young Earth and a Mars-sized object called Theia. Simulations show the impact could have blasted enough debris into orbit to form the moon. But even this theory isn't perfect. Lunar samples reveal oxygen isotopes almost identical to Earth's, which shouldn't happen if Theia was a separate body. Some researchers argue Theia might have had a similar composition, but that feels like a convenient fix rather than an answer. And then there's the strangest clue of all. The moon's crust is thinner on the side facing Earth, as if something sculpted it deliberately. Was it tidal forces, or could there have been another, more mysterious influence at work? Every rock brought back from the Apollo missions deepens the enigma. The moon's origin isn't just a scientific debate, it's a cosmic whodunit, and we're still missing the biggest piece of the puzzle. Right when we thought the moon couldn't get any stranger, we stumble upon one of the most baffling discoveries in lunar history, evidence that it might be hollow. Imagine dropping a hammer on a giant metal gong and hearing it reverberate for hours. Now picture that happening on the moon. That's exactly what occurred during the Apollo missions when astronauts deliberately crashed their discarded lunar modules into the surface. The resulting vibrations weren't just odd, they defied every expectation. In 1969, Apollo 12's seismometers recorded something extraordinary. After the lunar module crashed, the moon didn't just shake, it rang like a bell for over an hour. Later, Apollo 13's third stage booster was intentionally sent smashing into the surface, and the vibrations lasted an unbelievable 3 hours. Even small meteor impacts produced prolonged reverberations. This wasn't just unexpected, it was scientifically bizarre. Planets and moons typically absorb seismic waves quickly due to their dense, solid compositions. But the moon acted like a hollow sphere, amplifying the vibrations instead of muffling them. Mainstream scientists scrambled for explanations. Maybe the moon's surface was made of porous rock that trapped vibrations. Or perhaps its dry, rigid crust lacked the water and sediment that dampen quakes on Earth. But neither theory fully accounts for the sheer duration of the ringing. Some researchers, like Dr. Sean Solomon of the Massachusetts Institute of Technology, openly admitted the data pointed toward a moon with a far less dense interior, maybe even cavernous voids beneath the surface. This led to an even more radical idea. Could the moon be artificially hollow? Not long after the Apollo missions, classified Soviet documents and leaked NASA reports hinted at whispers within the scientific community, suggestions that the moon's interior might contain vast, unnatural cavities. Even famed astronomer Carl Sagan once mused that a natural satellite simply shouldn't behave this way. Artist renditions based on seismic data paint a surreal picture, an outer shell just miles thick, concealing a labyrinth of caverns or even geometric structures. Some theorists propose these could be remnants of ancient alien engineering, while others argue they're natural formations from volcanic tunnels long since collapsed. But if nature carved these hollow spaces, why do the echoes last so unnaturally long? And why do certain regions of the moon's interior reflect seismic waves as if they're bouncing off smooth, metallic surfaces? NASA's official stance dismisses the more sensational claims, chalking it up to unique geology, but the data remains undeniable and unexplained. Whether the truth involves hidden lava tubes, alien megastructures, or something even weirder, one thing is clear: our moon doesn't just sit silently in the sky. It rings, and that ringing might be the biggest clue yet that we've barely scratched the surface of its deepest secrets. For centuries, observers have spotted something bizarre happening on the moon, flashes of light that shouldn't be there. These aren't meteor strikes or camera glitches. They're sudden bursts of crimson, glowing blue mist, or unexplained patches of brightness that flicker across the lunar surface before vanishing without a trace. Astronomers call them Transient Lunar Phenomena, or TLP, and they've been documented since at least the 12th century. Even Galileo, peering through his primitive telescope, noted odd fluctuations in brightness that defied explanation. Take the famous case of the crater Aristarchus, a hotspot for these eerie events. In 1969, Apollo 11 astronauts reported seeing a strange glow emanating from its depths just days before their historic landing. Decades later, amateur astronomers still routinely capture flashes in the same region, sometimes lasting mere seconds, other times pulsing for hours. High-definition time lapses reveal them as unmistakable: pinpricks of light flaring up in the darkness, or vast, hazy patches creeping across the lunar plains like some otherworldly fog. Yet despite hundreds of credible sightings, mainstream science has largely ignored TLPs. No major space agency has dedicated a mission to study them. Theories range from solar radiation interacting with lunar dust to outgassing from underground cavities, but none fully explain why these flashes cluster in specific areas, or why some witnesses describe geometric patterns within the glow. Even more intriguing are the accounts from professionals. In 2012, a team at the University of Arizona recorded a TLP so bright it briefly outshone nearby stars. Then there's the chilling testimony from Soviet astronomer Nikolai Kozyrev, who in 1958 spectroscopically confirmed a crimson eruption in Alphonsus crater, a chemical reaction impossible under known lunar conditions. Amateur astronomers today continue documenting TLPs with ever sharper technology, but their findings often get dismissed as optical illusions. Meanwhile, declassified CIA files hint at Cold War-era concerns that these lights weren't natural at all. Whether it's trapped radioactive gases, alien activity, or something beyond our current understanding, one thing's certain: the moon isn't the dead, silent world we've been led to believe. It's alive with mysteries flickering in the shadows, waiting to be decoded. If the moon's surface were as fragile as scientists once believed, its craters should look very different. Take a close look at Gassendi, a massive impact site over 60 miles wide, yet barely 1 mile deep. That's like dropping a boulder into soft dirt, only to have it leave a faint imprint. According to standard physics, a crater that wide should be at least 4 times deeper. But across the lunar surface, this anomaly repeats itself: shallow depressions where there ought to be gaping chasms. Crater depth depends on 2 key factors: the force of the impact and the composition of the ground. On most planetary bodies, the math holds: bigger collisions carve deeper holes. But the moon flips this logic on its head. Compare Gassendi to Arizona's Meteor Crater, just 3,000 feet wide yet over 500 feet deep. Scale that up to lunar proportions and Gassendi should plunge 12 miles downward. Instead, it's shockingly shallow, as if something beneath the surface absorbed the blow. High-resolution scans reveal even stranger details. The floors of these craters are often perfectly flat, lacking the central peaks or rubble piles seen elsewhere in the solar system. Some even have concentric rings, like ripples frozen in stone. Mainstream explanations point to an ancient magma ocean that solidified into an ultra-dense layer beneath the crust. Others suggest the moon's interior contains materials far harder than anything found on Earth, perhaps metallic composites or crystalline structures we've yet to discover. But there's an even more radical theory. In 1970, Soviet scientists analyzing lunar mission data proposed that certain regions might be shielded by an artificial substructure, something designed to absorb impacts. When NASA Lunar Reconnaissance Orbiter mapped Gassendi in 3 dimensions, it found the crater floor had an oddly uniform density, unlike the fractured bedrock expected from a violent collision. Side-by-side simulations tell the story. A typical impact at this scale should have shattered the lunar crust, leaving jagged cliffs and chaotic debris. Instead, Gassendi looks like it hit a cosmic trampoline, the energy dispersed horizontally rather than vertically. Whether the cause is natural or something beyond our current understanding, one thing's clear: the moon's surface doesn't behave like any other celestial body we've studied. Those impossibly shallow craters aren't just quirks of geology, they're clues etched into the moon's face, waiting to tell us what really lies beneath. Stretching across the moon's surface like ghostly brushstrokes, lunar swirls are some of the most visually striking and scientifically perplexing features in our solar system. Picture this: delicate, glowing tendrils, some spanning dozens of miles, curling across the gray plains with an almost artistic precision. The most famous, Reiner Gamma, resembles a cosmic calligraphy stroke frozen in time. But here's what makes these formations truly bizarre: they refuse to darken. While the rest of the moon's surface weathers over eons, battered by solar radiation and micrometeorites, these swirls remain starkly bright, as if something is shielding them from the ravages of space. Scientists first assumed they were seeing tricks of light and shadow, but high-resolution images from NASA, a lunar reconnaissance orbiter, revealed the truth. These swirls aren't topographic. They don't rise above or sink below the surface. Instead, they're like stains, impossibly pristine against the darkened lunar regolith. Even stranger, they overlap craters and ridges without interruption, as if painted onto the landscape by an unseen hand. The leading theory points to magnetism. Orbital scans show the swirls align with localized magnetic fields, some of the strongest on the Moon. Researchers propose these fields deflect solar wind, preventing the iron-rich soil from darkening. But there's a glaring flaw. Not all magnetic anomalies coincide with swirls, and some swirls have barely detectable fields. If magnetism alone explains them, why do other magnetized regions look utterly ordinary? Then there's the comet hypothesis. Some scientists suggest a grazing impact by a comet's icy core could have scattered surface material, creating these patterns. The problem: no impact scar or debris field matches the swirl's scale or precision. A comet strike violent enough to create Reiner gamma would have left catastrophic fractures, yet the surrounding terrain is eerily undisturbed. Perhaps most puzzling of all are the swirl's unnatural edges. Unlike wind-blown dunes or lava flows which fade gradually, these features have razor-sharp boundaries. Magnetic field overlays reveal an uncanny symmetry, with some swirls forming near-perfect loops. Could this be evidence of buried mineral deposits or something more exotic? Apollo-era data hinted at metallic veins beneath certain swirls, but no mission has dug deep enough to confirm. Theories abound, from electrostatic dust levitation to ancient volcanic activity. Yet none fully explain why these luminous patterns exist nowhere else in the solar system. One thing's certain: the Moon's swirls aren't just geological oddities. They're cosmic puzzles glowing faintly in the darkness, daring us to unravel their secrets. In 1967, NASA Lunar Orbiter 3 captured something impossible: a jagged tower rising 5 miles above the Moon's surface in a region called Sinus Medii, the Bay of the Center. The photographs showed a slender, needle-like structure casting an unmistakable shadow across the lunar plain, taller than Mount Everest and thin enough to defy conventional geology. But here's where the mystery deepens. By the time later missions mapped the area, the tower had vanished from official charts as if it never existed. Enhanced images reveal unsettling details. The structure wasn't some trick of light. Its edges were razor-sharp, with geometric precision unlike any known natural formation. Amateur astronomers using modern software have reconstructed it in 3 dimensions, showing a base wider than Manhattan and a tapering peak that seems to glint in the sunlight. Compare it to Earth's tallest rock spires like the Devil's Tower in Wyoming, and the differences are staggering. Wind and erosion carve our planet's spires over millennia, but the Moon lacks atmosphere or weather to shape such a flawless monolith. Mainstream explanations crumble under scrutiny. Some scientists dismissed it as a camera artifact, but multiple frames from Orbiter 3 showed the tower from different angles, confirming its physical presence. Others suggested it could be a hardened lava fountain, frozen mid-eruption billions of years ago. Yet nothing in volcanology accounts for a 5-mile-tall spire with no visible debris field or secondary vents. The tower stands alone, untouched by the chaotic terrain around it. Then there's the erasure. Why would NASA scrub such a prominent landmark from later maps? Conspiracy theorists point to leaked 70s-era memos hinting at non-natural anomalies in Sinus Medii documents later classified under national security pretexts. Even more intriguing are the accounts from Apollo mission planners who allegedly avoided landing near the region despite its flat, ideal terrain. Could this have been something more than a quirk of lunar geology? Ancient alien theorists propose the tower might have been a marker or beacon, its purpose lost to time. Others speculate it was a crystalline formation, its reflective properties making it appear artificially smooth. But the most unsettling possibility, that it wasn't erased, that it simply wasn't there when later orbiters passed by. If so, the Moon's secrets aren't just buried in its past. They might still be shifting, hiding in plain sight, waiting for the right moment to reveal themselves again. In 1994, a declassified image from the Pentagon's Clementine mission sparked a firestorm, a towering, jagged structure jutting from the moon's surface near Euclid crater, piercing the black sky like a shattered skyscraper. Dubbed the Shard, this bizarre formation appeared to rise over 9 miles high, casting a long, angular shadow across the lunar plain. Nearby, a second anomaly, a perfect cube, its edges unnaturally straight, hovered just above the terrain, as if suspended by invisible forces. These weren't blurry smudges or pixelated artifacts. The Clementine probe's high-resolution camera captured them with startling clarity, igniting debates that still rage today. Enhanced zoom sequences reveal details that defy easy dismissal. The Shard's surface fractures in geometric patterns, resembling shattered glass rather than eroded rock. Its base anchors into the regolith at an odd angle, with no visible debris field to suggest a meteor impact or volcanic ejection. As for the cube, its dimensions align with near mathematical precision, 90-degree corners, uniform shading, and an eerie symmetry absent in natural lunar geology. Planetary scientists initially blamed lens flares or data corruption, but Clementine's multiple passes showed both objects from different sun angles, confirming their physical presence. Leading geologists like Dr. Bruce Cornett have analyzed these images frame by frame. In one striking comparison, they overlaid the Clementine photos with known lunar rock formations. The Shard's proportions dwarf anything in nature. Imagine stacking 20 Burj Khalifas end to end and planting them vertically on the moon. The cube, meanwhile, mirrors no known crystalline structure in the solar system. Defenders of the artifact theory point to Clementine's star tracker occasionally misaligning, but that wouldn't explain why anomalies only appear in this specific region. Then there's the context. Euclid crater sits at the moon's 0 point, where latitude and longitude lines converge, a deliberate landmark for early astronauts. Coincidence or something more? Apollo-era maps show this area was flagged for special observation decades before Clementine's discovery. Russian astrophysicist Dr. Alexander Popov once claimed Soviet probes detected electromagnetic pulses near Euclid in the 70s, though records remain classified. Mainstream astronomy leans toward pareidolia, our brains imposing familiar shapes on random patterns. Yet even skeptics admit these images push the limits of that explanation. The Shard and the cube don't just suggest intelligent design, they demand it. Unless, of course, we've stumbled upon a geological freak so unprecedented it rewrites planetary science. Either way, one truth remains. The moon keeps presenting us with riddles that challenge not just what we see, but how we dare to interpret it. During the live broadcast of Apollo 11, millions heard Neil Armstrong's famous words as he stepped onto the moon, but few caught the quiet exchange just before, a transmission abruptly cut from public feeds. According to former NASA employees, Armstrong reported seeing 2 massive, unidentified objects resting on the crater rim near their landing site. The original audio, later leaked through amateur radio operators, captures his tense whisper. "They're here, they're parked on the edge of the crater watching us." Seconds later, Mission Control ordered a switch to a medical channel, and the rest of the conversation vanished. Even decades later, NASA insists it was static interference. But the timing raises questions. Why silence the crew at the exact moment they spotted something unexplainable? Then there's Apollo 12, shadowed by its own enigma. As the lunar module descended, astronauts Pete Conrad and Alan Bean reported a flashing light trailing them. No meteor, no reflection, just a silent pulse keeping perfect pace with their craft. Telemetry data shows the object matched every maneuver, even hovering when they did. Conrad's live mic catch, "That's no damn stray bolt," was later scrubbed from mission transcripts. Thermal scans of the landing zone added another layer. Post-landing images revealed 3 distinct heat signatures radiating from nearby rocks, despite the moon's surface being frozen at -200 degrees Fahrenheit. Engineers expected the descent engine's exhaust to warm the ground briefly, but these hotspots lingered for hours, clustered in a perfect triangle. Perhaps most chilling are the lost Apollo tapes. Over 700 boxes of mission footage, original, high-resolution recordings, were accidentally erased in the 1980s according to a NASA audit. Among them, the so-called sistercraft footage from Apollo 16, where astronauts John Young and Charlie Duke allegedly filmed a second lunar module sitting empty in a crater. Duke's decades-later interviews hint at the truth. "We weren't told everything, and some things we saw we couldn't talk about." Even the declassified portions of these missions read like science fiction. Transcripts describe metallic scraping sounds during moonwalks, as if something moved beneath the surface. Infrared scans show patches of the landing sites glowing at temperatures impossible for inert rock. And then there's the infamous music heard during Apollo 10's pass over the far side, an unearthly, oscillating hum that astronauts later admitted they nearly reported to NASA until realizing no one would believe them. The evidence isn't just in the anomalies, it's in the reactions. Flight directors abruptly changing frequencies, astronauts' voices tightening with unease, the way certain images were locked away for calibration purposes and never released. Whether these encounters were with secret Soviet tech, natural phenomena, or something beyond our understanding, one thread connects them all. The moon, it seems, was waiting for us. And if the Apollo crew's hushed confessions are any indication, we may not have been the only ones watching. In 1967, NASA, a lunar orbiter, captured an image that would become one of the most hotly debated anomalies in lunar history. A towering, pyramid-shaped structure casting a long, triangular shadow near the moon's Marius Hills region. The photograph showed crisp, symmetrical edges and a base wider than a football field, starkly contrasting with the surrounding jagged terrain. But when follow-up missions scanned the same coordinates years later, the pyramid was gone. No debris, no collapse, just empty lunar dirt where a massive structure once stood. Enhanced scans of the original image reveal impossible details. The pyramid's facets reflect sunlight with geometric precision, as if cut from polished stone. Shadow analysis suggests a height exceeding 1,500 feet, 3 times taller than the Great Pyramid of Giza, yet the real mystery lies in its disappearance. Lunar Orbiter 5 revisited the site in 1968, finding no trace of the structure. Skeptics claim it was a trick of light or a camera artifact, but side-by-side comparisons tell a different story. The original image shows the pyramid anchored firmly to the surface, its shadow matching the angle of the sun precisely. Subsequent photos from the same angle reveal only undisturbed regolith, as if the object vanished without disturbing a single grain of dust. Geologists proposed it might have been an optical illusion, a rare alignment of boulders mimicking a pyramid. But boulders don't cast shadows with knife-edge symmetry, nor do they vanish without leaving scattered remnants. Others suggest it could have been a transient lunar phenomenon, a temporary structure formed by outgassing or electrostatic dust levitation. The problem: nothing in known physics explains how such a process could create and then erase a formation of that scale. Then there's the moving structure theory. Declassified Soviet lunar maps from the same era mark the Marius Hills region as a zone of instability, with notes describing ephemeral geological features. Rumors persist that Apollo mission planners deliberately avoided landing near the area despite its flat terrain. Could the pyramid have been some kind of movable artifact, shifting position beneath the surface or cloaking itself from subsequent observation? The most unsettling clue lies in the tracking lines. When researchers overlay the Orbiter 2 image with later scans, they find faint, ruler-straight depressions in the soil, almost like grooves left by something sliding away. No natural erosion pattern creates such marks. Whether the pyramid was a mirage, a geological fluke, or something far stranger, its brief appearance and silent disappearance remain one of the moon's most haunting puzzles. The camera didn't lie, but the truth, whatever it is, seems to be hiding in plain sight. Early lunar explorers expected to find craters, plains, and maybe the occasional mountain. What they didn't expect was a bridge. In 1953, astronomer John O'Neill peered through his telescope at Mare Crisium, the moon's Sea of Crises, and spotted something that defied logic, a 3-kilometer-long, arch-like structure spanning two jagged cliffs. His sketches and photographs showed a formation so precise, so unnervingly symmetrical, that it looked like something out of an engineer's blueprint. The media dubbed it O'Neill's Bridge, sparking debates about whether nature could carve such a flawless span, or if intelligence had a hand in its creation. At first glance, the bridge seemed impossible. Natural arches on Earth, like Utah's Rainbow Bridge, form over millennia from wind and water erosion. But the moon has no atmosphere, no flowing rivers, no weather to sculpt rock into delicate curves. O'Neill's photographs revealed a structure with a near-perfect parabolic curve, its underside smooth and unbroken, as if designed to bear weight. When skeptics dismissed it as pareidolia, the brain seeing familiar shapes in random patterns, O'Neill countered with detailed measurements. The bridge's shadow matched the angle of sunlight, proving it wasn't an optical illusion but a solid, physical object. Decades later, modern imaging technology brought new clues. High-resolution scans from NAS, a lunar reconnaissance orbiter, revealed the exact coordinates where O'Neill had documented the bridge. But the area showed no trace of the arch, just two weathered promontories with a gap between them. Had it collapsed or had it never existed? Digital recreations using O'Neill's original photos and lighting angles tell a different story. When researchers simulated the 1950s lunar sunrise, the shadows aligned exactly with his observations, confirming something had indeed cast that distinctive silhouette. Geologists proposed a radical explanation. Perhaps the bridge was a rare volcanic formation, a lava tube that hardened into a natural span. The problem: lava tubes on the moon typically collapse under their own weight, leaving ragged trenches, not smooth, freestanding arches. Others suggested a dry waterfall effect, where molten rock once poured between the cliffs and solidified midair. But no known volcanic process could create a 3-kilometer bridge without visible support columns or stress fractures. Then there's the timing. O'Neill's bridge appeared only under specific lighting conditions, vanishing when the sun climbed higher in the lunar sky. Some theorists speculate it might have been a transient structure, its surface reflecting light in a way that made it invisible from certain angles. Soviet probes in the 1970s allegedly detected unusual density fluctuations in the area, as if something hollow lay beneath the soil. Could the bridge have been the remnant of an ancient, buried architecture, its upper curve briefly exposed by a landslide or moonquake, the most haunting possibility? That it wasn't natural at all. In 2009, Japanese orbiter Selene spotted faint, linear depressions near the site, straight as a ruler, intersecting at right angles. No meteor impact or lava flow creates 90-degree turns. Whether O'Neill's bridge was a fleeting trick of light, a geological miracle, or something far more profound, its legacy endures as a reminder: the moon doesn't just hide its secrets. Sometimes it lets us glimpse them just long enough to leave us questioning everything we think we know. There's a patch of the moon where signals go to die, a 300-mile-wide zone near the crater Paracelsus C where radio waves simply vanish. It's not static, not interference, but a complete blackout, as if some invisible force swallows every transmission whole. Both NASA and Soviet probes confirmed it. Signals aimed at this region hit an impenetrable wall, while those skirting its edges passed through untouched. Imagine shouting into a canyon and hearing nothing, no echo, no reverberation, just silence. That's what happens when radio waves enter this dead zone, and no one can fully explain why. The first clue came in 1965, when the USSR's Lunar 6 probe abruptly lost contact as it passed over the area. engineers assumed a technical glitch until NASA, a lunar prospector, repeated the anomaly decades later. Meticulous scans revealed the blackout's borders were unnaturally precise, forming a near-perfect circle. Inside, no signal could penetrate, not even the high-frequency burst used for deep space communication. Outside, transmissions resumed instantly, as if the barrier had razor-sharp edges. Mainstream theories crumble under scrutiny. Some scientists proposed an ultra-dense mineral deposit absorbing radio waves, but lunar samples show no known material could block such a broad spectrum. Others suggested a massive lava tube beneath the surface, its metallic, rich walls acting like a Faraday cage. The problem: lava tubes don't form perfect circles, and their shielding effects are inconsistent. This blackout is absolute, uniform, more like an engineered jammer than a geological fluke. Then there's the timing anomaly. Apollo mission logs note that astronauts orbiting near Paracelsus C experienced unexplained clock drift, their instruments losing sync only over this region. Later, Japan's Selene orbiter detected localized magnetic pulses, brief, rhythmic bursts with no discernible source. Could something under the lunar surface be actively disrupting signals? Declassified documents hint at even stranger findings. According to a 1978 CIA memo, a classified U.S. experiment beamed a high-powered radar pulse into the zone. The signal didn't just disappear, it bounced back inverted, as if reflected by a surface designed to cancel it out. Visualizing the phenomenon only deepens the mystery. Animation overlays show radio waves striking an unseen dome, their paths bending sharply away or dissolving into nothingness. Compare this to Earth's ionosphere, which reflects certain frequencies, and the difference is startling. This isn't reflection, it's erasure. Conspiracy theorists point to whispers of buried alien tech, citing ancient astronaut hypotheses about the moon being an artificial construct. More sober analysts propose an ultra-rare natural phenomenon, perhaps a concentrated pocket of helium-3, an isotope abundant on the moon, interacting with solar wind in ways we don't yet understand. But neither camp can explain why the effect is so localized or why it mimics the behavior of human-made signal jammers. One thing's certain: this isn't just a dead zone. It's a deliberate blind spot, a patch of lunar real estate that refuses to be observed. Whether the cause is a freak of nature or something far more intentional, the message is clear. Some secrets aren't just hidden, they're guarded. For decades, scientists swore the moon was a desert, bone dry, lifeless, incapable of holding even a drop of water. Apollo astronauts brought back hundreds of pounds of lunar rock, and not a single sample showed signs of moisture. NASA's official stance was absolute. The moon had no water, no ice, no hydrogen, nothing. But then, something impossible started happening. Probes and satellites began detecting unmistakable signatures of water molecules clinging to the lunar surface, concentrated in shadowed craters where sunlight never reaches. The first crack in the dry moon theory came in 1994, when the Pentagon's Clementine mission bounced radio waves off the lunar poles. The signals returned with a telltale glint, a reflection pattern consistent with ice. Skeptics dismissed it as noisy data, but 9 years later, NASA, a lunar prospector, confirmed it. Its neutron spectrometer found hydrogen concentrations high enough to suggest millions of tons of water ice buried in permanently dark regions. Suddenly, the narrative shifted. Agencies that had spent years swearing the moon was drier than Earth's driest desert now spoke of valuable ice deposits and future resources for human exploration. The contradictions only deepened. India's Chandrayaan-1 orbiter in 2008 mapped water signatures across the moon's sunlit surface, places where liquid shouldn't survive for even a second under the vacuum of space. NASA follow-up mission L-Cross slammed a probe into the crater Cabeus, and the resulting plume contained not just traces of water, but enough to fill a dozen swimming pools. Yet the Apollo samples remained stubbornly dry. Re-examined with modern tools, they showed no hidden reservoirs. How could the same moon that drenched modern sensors in watery signals leave astronauts holding only parched rocks? Some scientists proposed a solar-wind interaction, where hydrogen particles from the sun bond with oxygen in the soil to create fleeting water molecules. Others pointed to ancient comet impacts, leaving behind ice that migrates slowly to the poles. But none of these explain why the water signals fluctuate, sometimes strong, sometimes faint, as if the moon breathes moisture in cycles we don't yet understand. The most unsettling twist came in 2020, when NASA's SOFIA Airborne Telescope detected water molecules in sunlit areas where temperatures soar past 200 degrees Fahrenheit. Liquid shouldn't exist there, not just ice, liquid water clinging to grains of lunar dust like morning dew. The discovery shattered every model of planetary science. Either our understanding of water in space is fundamentally flawed, or the moon is hiding its reserves in ways we've only begun to glimpse. Behind the science, another mystery lingers: the shifting official statements. Early NASA press releases downplayed water findings as contamination or instrument error. By 2010, the same agency was announcing game-changing ice deposits. Russia's lunar missions in the 1970s allegedly detected hydrated minerals, but the data vanished into Cold War archives. Even today, spectrometers on different orbiters return conflicting maps, some showing vast ice sheets, others mere traces. One theory suggests the water isn't evenly distributed, but locked in microscopic traps within lunar glass formed by meteor impacts. Another proposes underground reservoirs shielded from solar radiation. But the truth might be stranger. Lunar water behaves unlike any on Earth, appearing and disappearing with the lunar day, clinging where it shouldn't, vanishing where it should be abundant. Every new mission rewrites the rules, leaving us with a single haunting question. If the moon's water is so elusive, what else might be hiding in its shadows? Take a compass to the moon, and in most places its needle would lie still dead, useless, but land near eerie crater, and suddenly it springs to life, spinning wildly as if caught in an invisible storm. This isn't a malfunction, it's one of the moon's most baffling quirks: localized magnetic fields strong enough to scramble instruments, yet with no global magnetic core to explain their existence. These aren't just faint traces. Some patches generate fields 20 times stronger than the surrounding terrain, creating ghostly force fields that shouldn't be possible. Scientists first noticed these anomalies during the Apollo missions. When astronauts passed over certain regions, their magnetometers spiked unpredictably. The Riener gamma swirl, one of those luminous, ethereal patterns we discussed earlier, aligns perfectly with one of the strongest magnetic zones, as if whatever's beneath the surface is painting the landscape with invisible ink. Later orbiters mapped these hotspots in detail, revealing jagged, continent-sized patches where magnetism clings stubbornly, like scars from some ancient cosmic trauma. So how does a world without an active core generate such intense, localized fields? Earth's magnetism comes from its molten iron core churning like a dynamo, but the moon's core is small, cool, and geologically silent. One leading theory points to asteroid impacts. When massive objects slammed into the moon billions of years ago, the reasoning goes, they might have vaporized iron-rich material that later solidified into magnetized rock. But there's a glaring hole in that logic. Why do only certain impacts create these fields, while most leave no magnetic trace at all? Then there's the magnetized shell hypothesis. Some researchers propose the moon once had a molten core that generated a global magnetic field, which froze into pockets of rock as the core cooled. Imagine a candle flame snuffing out, leaving behind patches of wax still warm to the touch. The problem: lunar samples show these anomalies are too young. Some formed long after the core solidified. Visualizing the data only deepens the enigma. Heat maps of the magnetic hotspots glow like embers scattered across the lunar surface, clustered in strange geometric arrangements. Eerie Crater's field forms a near-perfect circle, while others streak across the landscape in straight lines, defying the chaotic nature of impact debris. Even stranger, instruments aboard India's Chandrayaan orbiter detected brief fluctuations, momentary surges where the fields strengthened and weakened, as if something beneath the soil was adjusting their intensity. Mainstream science hesitates to entertain more radical possibilities, but the evidence whispers tantalizing hints. Could these fields be remnants of ancient technology, buried machinery still pulsing with residual energy? Or perhaps natural crystalline structures, their atoms aligned in ways we've yet to discover? One thing's certain, the moon's magnetic ghosts aren't just scientific curiosities. They're clues, silent, persistent, and waiting for someone to decode their secrets. Beneath the moon's dusty surface lies a network of structures so precise, they look like they were carved by machines rather than nature. High-resolution orbital images reveal long, tubular formations with unnervingly straight edges, some stretching for hundreds of miles without a single curve or break. Scientists call them lunar hollows, but their appearance tells a stranger story. These aren't the twisted, collapsed lava tubes seen on Earth or Mars. They're smooth, uniform, and eerily geometric, as if someone bored through the moon's crust with a cosmic drill bit. Take the winding channel beneath the Marius Hills, first spotted by Japan's Selene orbiter. LiDAR scans show a cavernous tube stretching over 30 miles, its ceiling arched like a Gothic cathedral. But the real shock came when researchers analyzed its walls. Unlike natural caves which crumble and fracture over time, this tunnel's interior reflects light like polished glass, a phenomenon planetary geologists still can't explain. Side-by-side comparisons with Earth's lava tubes highlight the difference. Our planet's volcanic tunnels snake unpredictably, choked with rubble. The moon's tunnels look like subway shafts, their paths ruler straight even when crossing rugged terrain. Shaded relief maps reveal even more unsettling details. In the Ocean of Storms region, a grid-like network of tunnels intersects at perfect right angles, forming what looks like an underground highway system. Thermal imaging adds to the mystery. These passages retain heat long after sunset, suggesting they're lined with material far denser than surrounding rock. Some researchers propose these are fossil lava rivers, frozen in place billions of years ago when the moon still had volcanic activity, but that doesn't account for the precision. Molten rock doesn't flow in 90-degree turns. Then there's the scale. One tube near the crater king measures nearly 2 miles wide, large enough to fit Manhattan inside with room to spare. NASA's Grail mission detected strange gravitational anomalies along these tunnels, as if their mass isn't uniform. Certain sections appear hollow, while others register denser than solid iron. The most perplexing finding, several tubes dead end abruptly, terminating in smooth, concave walls that look more like sealed doorways than collapsed ceilings. Theories range from the plausible to the extraordinary. A few geologists suggest these could be lunar dikes, vertical sheets of magma that hardened into glassy walls. Others point to electrostatic forces, where charged lunar dust welded itself into bizarre shapes over eons. But the most tantalizing hints come from declassified Apollo-era reports. Astronauts allegedly dropped seismic charges near suspected tunnel entrances, recording echoes that suggested vast, empty chambers beneath. One memo mentions harmonic resonance patterns, inconsistent with any known geological formation, as if the tunnels were designed to carry sound in specific ways. Whether these glassy corridors are natural wonders or something more, they rewrite our understanding of the moon's interior. Down there in the darkness, beyond the reach of sunlight, entire labyrinths wait in silence, their smooth walls holding secrets we're only beginning to uncover. The moon's gravitational field shouldn't be this messy. In the 1960s, NASA scientists preparing for the Apollo missions noticed something bizarre. Spacecraft orbiting the moon would suddenly lurch, speeding up or slowing down for no apparent reason. Detailed mapping revealed the culprit: massive, invisible regions where gravity spiked unpredictably, as if giant chunks of lead were buried just beneath the surface. They called these zones mass concentrations or mascons, and their shapes defied all logic. Some mascons form perfect circles, their edges so precise they look like targets painted underground. The most famous sits beneath Mare Imbrium, a 200-mile-wide bullseye of gravity strong enough to tug passing satellites 10 miles off course. Others, like the one under Mare Serenitatis, create jagged geometric patterns visible only on gravity maps, pentagons and hexagons lurking beneath the dust. How does a world with no plate tectonics or active volcanism produce such freakish gravitational anomalies? The leading theory points to ancient lava seas. Billions of years ago, asteroid impacts carved out giant basins which later flooded with molten rock. As this lava cooled, it supposedly densified into iron-rich basalt, creating localized gravity spikes. But here's where the explanation falls apart. Computer simulations show these lava flows couldn't account for the mascon's razor-sharp edges or their unnatural symmetry. Molten rock doesn't harden into perfect circles, it crackles and fractures randomly. Yet mascons like the one under Mare Crisium have near mathematical circular boundaries, as if something sculpted them deliberately. Then there's the density problem. Some mascons register 30% denser than surrounding rock, a variance unmatched anywhere in the solar system. Soviet probes in the 1970s detected bizarre sub-mascon structures smaller, even denser nodules clustered at their cores, like metallic seeds planted underground. When NASA's Grail mission mapped these zones in ultra-high resolution, the data revealed something even stranger. Certain mascons generate microgravity vortices, tiny whirlpools of force where the pull spikes and dips rhythmically, like the heartbeat of some buried machine. Alternative theories range from the provocative to the downright unsettling. A few researchers suggest mascons might be the remnants of colossal impactors, fragments of the asteroids that created the moon's basins, still lodged deep below. Others propose exotic matter, ultra-dense minerals formed under pressures impossible on Earth. But the most controversial idea comes from a leaked 1982 Air Force study, which speculated that perfectly circular mascons could be artificial mass implants, deliberately placed objects designed to alter the moon's gravitational signature. Visualizing the evidence makes the mystery even more compelling. Gravity gradient maps paint mascons as glowing red hotspots against cool blue plains, their boundaries unnervingly crisp. Orbital animations show spacecraft wobbling like moths caught in invisible webs as they pass overhead. And when scientists overlaid mascon locations with other lunar anomalies, they found eerie correlations. Many sit directly beneath regions notorious for transient lights, magnetic spikes, or those glassy tunnels we discussed earlier. Whether these gravitational ghosts are natural oddities or something more, their existence forces us to rethink the moon's history. Every probe sent to map them raises new questions, and every theory leaves gaping holes. One thing's certain: whatever lies beneath those dead, gray plains doesn't play by the rules of planetary science. The mascons aren't just quirks of gravity, they're fingerprints. And they're waiting for us to figure out who left them there. Back in 1956, an amateur astronomer named Dinsmore Alter pointed his telescope at the moon's Alphonsus crater and captured something that shouldn't exist: a 12-mile-wide vapor cloud hovering silently above the lunar surface. The photograph, taken through the modest lens of his backyard observatory, showed a hazy, ethereal mass clinging to the crater's rim like a ghostly shroud. What made this image so unsettling wasn't just the cloud itself, but the fact that nothing like it has ever been seen since. No professional observatory, no high-tech orbital probe, not even the Apollo missions have documented a phenomenon quite like it. Side-by-side comparisons with known lunar outgassing events only deepen the enigma. Modern satellites have caught wisps of gas escaping from certain craters, brief puffs of radon or carbon dioxide, barely visible and gone in seconds. Alta's cloud, however, was massive, persistent, and eerily structured. Enhanced scans of the original glass plate revealed tendril-like filaments weaving through the mist with a density and opacity that defy conventional explanations. If it was just outgassing, why hasn't Alphonsus or any other crater produced a cloud of this scale again? Theories range from the plausible to the extraordinary. Some scientists argue it could have been a one-time release of trapped volatile compounds, a lunar burp of sorts. Others point to solar flares. A sudden burst of radiation might have agitated subsurface ices, vaporizing them into a temporary plume. But the timing doesn't add up. No significant solar activity was recorded that night, and the cloud appeared stationary for hours, unaffected by the vacuum of space or the moon's negligible atmosphere. Then there's the shadow detail. Advanced reprocessing of Alta's image shows the cloud casting a faint but detectable shadow on the crater floor, proof it was a physical phenomenon, not a camera artifact or developing error. Modern spectral analysis, though limited by the photograph's age, suggests the cloud's composition didn't match any known lunar gases. It lacked the telltale signatures of water vapor or carbon dioxide, leaving researchers to speculate about exotic compounds or something even stranger. The most haunting question remains, why Alphonsus? This crater is no stranger to anomalies. It's where astronomer Nikolai Kozyrev spectroscopically confirmed a crimson glow in 1958, and where Apollo crews reported unusual electromagnetic readings. Some conspiracy theorists whisper about hidden vents or even machinery beneath the surface, though mainstream science dismisses such claims. Yet the evidence lingers, a single, unverified moment of lunar atmosphere where none should exist, captured not by a government satellite but by a lone stargazer with a camera. Perhaps the cloud was a fluke, a cosmic coincidence never to recur. Or maybe it was a glimpse into a process we still don't understand, a reminder that the moon, even after decades of study, keeps its most fleeting secrets close. Whatever it was, Alta's photograph stands alone, a 12-mile question mark hanging in the blackness of space, waiting for an answer that may never come. While the moon itself holds countless mysteries, some of the most unsettling phenomena aren't embedded in its surface. They're moving above it. Across decades of footage from the International Space Station, telescopes, and lunar orbiters, lights have been captured gliding across the moon's dark side in formations that defy conventional explanation. These aren't scattered meteors or random satellite flares. They're coordinated, sometimes appearing in perfect triangular or V-shaped arrangements, their paths intersecting at angles that make no sense for human-made objects. Take a sequence filmed by the ISS in 2015, where three luminous dots emerge from the shadowed edge of the moon. At first glance, they could be dismissed as satellites until their trajectories are plotted. Unlike predictable orbital paths, these lights accelerate, decelerate, and even reverse course. Side-by-side analysis with known satellite routes confirms the discrepancy. Commercial and military satellites follow strict, published orbital parameters, yet these objects veer wildly off those grids, executing maneuvers that would require impossible amounts of fuel if they were man-made. Then there's the Hubble footage from 1992, recently declassified. A cluster of 5 light streaks across the lunar disk in a staggered line, maintaining perfect spacing despite the moon's uneven gravity field. Astronomers initially flagged them as debris, but the objects slowed down as they approached the terminator, the boundary between lunar day and night, as if reacting to the terrain below. No known space debris behaves this way. Even more perplexing is their luminosity. these lights don't reflect sunlight like satellites or space junk. They glow steadily, even in the moon's frigid shadow. The most compelling evidence comes from amateur astronomers. In 2019, a team in Chile tracked a formation of 7 lights performing a synchronized dance over the far side. High-resolution time-lapses show the objects executing abrupt 90-degree turns while maintaining formation, a feat impossible for conventional spacecraft without tearing themselves apart from G-forces. When their paths are overlaid, the pattern resembles a navigation grid, with lights intersecting at precise nodes before dispersing. Satellite experts have analyzed the footage frame by frame, ruling out Starlink clusters, rocket stages, or any known celestial phenomena. What makes these sightings so compelling is their recurrence in controlled environments. NASA's Lunar Reconnaissance Orbiter has captured similar anomalies, though the images are often labeled as lens artifacts in official releases. Yet when the same camera records known satellites, they appear as expected tiny, dim specks moving in straight lines. The unidentified lights, by contrast, pulse erratically and leave faint afterglows in their wake. Critics argue these could be lens flares or equipment malfunctions, but the data tells a different story. Multiple independent observers, from professional astronauts to backyard astronomers, have documented identical formations decades apart using different equipment. The odds of identical glitches appearing across telescopes, space station cameras, and lunar probes strain credulity. Perhaps the most chilling detail lies in the timing. Many of these events cluster around the moon's most enigmatic regions, areas like the Aristarchus Plateau or Mare Crisium, where other anomalies like transient lunar phenomena and magnetic spikes are frequently reported. It's as if whatever's beneath the surface occasionally sends scouts above it, patrolling the darkness with purpose we can't yet decipher. Whether these lights are natural plasma discharges, secret human technology, or something beyond our understanding, one thing is certain: the moon's mysteries aren't confined to its dust and rock. Some of them are alive, moving, and watching from the shadows. The moon's whisper-thin veil of gas shouldn't be there. By all scientific logic, our lunar companion should be utterly airless, a vacuum-sealed relic where not a single molecule drifts unanchored. Yet sensitive instruments have detected traces of neon, helium, and even argon clinging to the surface like spectral fingerprints, forming what scientists call an exosphere. This isn't an atmosphere in the traditional sense. It's more like a ghostly wisp, a billion times thinner than Earth's air, barely dense enough to register. But here's the kicker: these gases come and go in rhythmic patterns, pulsing with the lunar day as if the moon itself is breathing. The first clues emerged during Apollo missions, when astronauts left behind detectors that sniffed out minute amounts of helium and argon. At the time, researchers shrugged it off, maybe residual gases from the solar wind, they thought, or ancient volcanic leftovers slowly seeping through cracks. But decades later, NASA LADEE orbiter painted a far stranger picture. Its ultra-sensitive spectrometers mapped neon clouds billowing over sunlit highlands, while pockets of argon pooled in shadowed regions like invisible lakes. The distribution wasn't random. Neon flourished where solar radiation hit hardest, suggesting it was being blasted free from the soil. Argon, however, behaved differently, concentrating in specific basins, as if fed by hidden underground vents. Visualizing this phantom atmosphere reveals even more puzzles. Animated models show the gases don't disperse evenly. Neon forms shimmering, ephemeral clouds that vanish at sunset. Helium slinks across the surface in rippling waves, following magnetic field lines like iron filings, and argon, it defies expectation entirely, gathering in the coldest, darkest craters, places where gas should freeze solid. Side-by-side comparisons with Mercury, another airless world, highlight the moon's uniqueness. Mercury's exosphere is steady and predictable, while the moon's fluctuates wildly, with argon levels sometimes spiking 100-fold in hours. So where is this gas coming from? The leading theory points to the solar wind, a constant stream of charged particles from the sun that might implant gases into the lunar soil, later released by micrometeorite impact. But that doesn't explain the argon. This heavy noble gas shouldn't be carried by solar wind, and the moon hasn't had active volcanoes for billions of years. Some researchers propose it seeping from deep mantle reserves, preserved since the moon's fiery birth. Others speculate about cold-trapping argon atoms migrating over eons to polar cold spots where they accumulate like cosmic dew. Then there's the wild card. NASA Artemis probes recently detected short-lived bursts of oxygen and nitrogen, two gases that have no business appearing together on the moon. The readings lasted mere minutes before vanishing, as if something below had briefly exhaled. Could there be underground reservoirs, pockets of volatile elements stirring after eons of silence? Or might the moon still harbor trace geological activity, its crust flexing just enough to squeeze out ancient gases like a stone dripping water in a desert? Every new mission adds pieces to the puzzle, but the full picture remains tantalizingly out of reach. The moon's exosphere isn't just a scientific curiosity, it's a dynamic, ever-changing boundary between the known and the inexplicable. And with each passing orbit, it whispers a question. If even the airless moon holds traces of atmosphere, what other secrets might be hiding in plain sight, just beyond our instrument's grasp? During the Apollo missions, astronauts and orbiting probes documented something utterly bizarre: patches of the moon's surface that acted less like dusty rock and more like polished mirrors. Thermal scans revealed these zones absorbed sunlight during the day like any other lunar terrain, but when night fell, they didn't cool down as expected. Instead, they radiated heat away at an unnervingly slow pace, as if something beneath the surface was actively retaining or even generating energy long after sunset. The first anomaly appeared in scans of the crater Tycho, where infrared sensors detected a circular patch roughly half a mile wide emitting heat signatures inconsistent with surrounding basalt. Side-by-side thermal comparisons showed neighboring areas plunging to -150 degrees Celsius within minutes of darkness, while this zone lingered at -50 for hours. Scientists initially dismissed it as a fluke, perhaps a rare outcropping of dense metallic ore, but then Lunar Orbiter 5 spotted another, this time in the heart of the Sea of Tranquility, its reflective surface glinting like liquid silver in orbital photos. Thermal imaging confirmed the same impossible behavior: rapid heat absorption, sluggish cooling, and an albedo reflectivity 3 times higher than typical lunar soil. Mainstream explanations crumble under scrutiny. Metallic meteorite debris could account for some reflectivity, but not the thermal retention. Iron-rich asteroids striking the moon would scatter molten metal in chaotic splatters, not smooth geometric patches. The cooling rates posed an even bigger puzzle. On Earth, materials like copper or aluminum shed heat quickly due to conduction. These lunar zones behaved more like solar panels, absorbing energy efficiently, then releasing it at a controlled, almost deliberate pace. Then came the most unsettling discovery. When researchers overlaid maps of these reflective spots with other lunar anomalies, they found eerie correlations. Many coincided with gravitational mascons, those dense underground patches we discussed earlier. Others aligned perfectly with regions notorious for transient lunar phenomena, as if the mirror-like surfaces were somehow connected to the flickering lights and unexplained glows seen for centuries. Theories range from the plausible to the extraordinary. Some planetary scientists propose these patches could be vast sheets of naturally occurring iron-titanium deposits, forged under conditions we've yet to replicate in labs. Others speculate about cold mirrors, hypothetical structures that passively collect and store solar energy beneath insulating layers of dust. But the most radical suggestion comes from declassified NASA contractor reports, which hint at the possibility of anomalously smooth engineered surfaces glimpsed in classified high-resolution scans. One particularly cryptic memo mentions thermal signatures inconsistent with known natural processes, alongside hand-drawn sketches of hexagonal patterns. Whether these mirror zones are geological oddities or something more, their existence forces us to reconsider the Moon's relationship with energy. Unlike Earth, where heat dissipates through air and water, the lunar surface is a vacuum insulator, making these slow cooling patches even more inexplicable. Every new orbital sensor sent to study them adds another layer of mystery, capturing reflections so sharp they seem to defy eons of micrometeorite pitting. One thing's certain, the Moon isn't just reflecting sunlight. In these strange, silvery patches, it's reflecting questions, and so far, science has no clear answers. The Moon trembles in ways that defy everything we know about planetary geology. Unlike Earth, where quakes ripple randomly from shifting tectonic plates, moonquakes follow a chillingly precise pattern, originating almost exclusively from depths between 800 and 1,100 kilometers, as if something deep below the surface is keeping strict rhythmic time. First detected by Apollo seismometers, these vibrations weren't the occasional shudder of a cooling world. They were systematic, clustered in specific zones, their waves traveling through the lunar interior with eerie uniformity. Plot the data on a graph, and the pattern leaps out a straight vertical band of seismic activity at that exact depth range, with almost no quakes occurring above or below. Earthquakes scatter like ink blots across depth charts, but moonquakes form a razor-thin line, as though following an invisible rulebook. The leading theory points to tidal forces. As the Moon's orbit brings it closer to Earth, our planet's gravity supposedly tugs on its rigid crust, creating stress fractures at precise depths. But here's where the math unravels. Tidal forces should produce shallow quakes near the surface, where strain is greatest, not deep in the mantle. Even stranger, Apollo records show some moonquakes recurring like clockwork every 27 days, aligned not with lunar perigee but with entirely different celestial cycles. Then there's the waveform anomaly. When quakes ripple through Earth, their signatures look like chaotic scribbles, energy diffracted by molten layers and uneven rock. Moonquakes, by contrast, produce clean, repeating echoes, as if bouncing off smooth, reflective surfaces deep underground. Some seismologists suggest this points to a broken plate theory, massive slabs of the lunar mantle fractured during ancient impacts now grinding against each other. But that doesn't explain why the quakes avoid the Moon's lower mantle entirely, clustering only in its middle layer like a drumbeat in a hollow chamber. Graphing moonquake depths over time reveals another oddity. Their frequency isn't constant. Between 1969 and 1977, Apollo instruments recorded surges every 6-month periods when quakes spiked tenfold, then vanished again. No known astronomical event matches this cycle. Some researchers speculate about lunar tides in a hypothetical subsurface ocean of magma, but orbital scans show the Moon's interior is bone dry and geologically stagnant. Others point to electromagnetic triggers, noting that many quakes coincide with solar wind surges. Yet nothing in mainstream physics explains how charged particles could penetrate hundreds of kilometers of rock to destabilize the mantle. The most unsettling possibility that these aren't natural quakes at all. Declassified Soviet lunar reports from the 1970s mention harmonic resonance patterns in moonquakes' frequencies that resemble engineered vibrations rather than tectonic shifts. Later, a leaked NSA document hypothesized about acoustic anomalies consistent with mechanical stress release mechanisms. Even mainstream papers admit the waveforms look artificially amplified, as if something beneath the surface is focusing the energy. Whether these deep tremors are natural or something more, their precision remains a geophysical paradox. The Moon doesn't just quake, it thrums, sending signals from depths we've barely begun to explore. And every ripple carries the same unspoken question: what exactly is down there, ticking like a clock in the dark? Earth's core is a churning dynamo of molten iron, spinning fiercely to generate our planet's protective magnetic field. The Moon, by contrast, seems almost hollow inside its core. If it exists at all, is shockingly tiny. Seismic data from Apollo missions paints a startling picture. Our lunar companion's core occupies less than 20% of its total volume compared to Earth's 50%. Some models even suggest the Moon might have no true metallic core at all, just a partially molten slurry of minerals barely denser than the surrounding mantle. This isn't just an academic curiosity, it's a cosmic paradox that unravels every mainstream theory of how moons form. Imagine slicing both worlds in half. Earth's cross-section reveals distinct layers: a solid inner core, liquid outer core, viscous mantle, and thin crust. The Moon's interior, however, looks unnervingly uniform, with seismic waves passing through its deep zones at speeds that suggest nothing resembling Earth's dense metallic heart. When researchers compared Apollo-era moonquake echoes with modern simulations, they found the vibrations behaved as if they were traveling through a fractured sponge rather than a differentiated planetary body. Even the Moon's faint magnetic patches, those localized anomalies we discussed earlier, originate from shallow crustal sources rather than deep internal dynamos. This missing core throws every lunar origin story into chaos. If the Moon formed alongside Earth from the same primordial dust cloud, why doesn't it have a proportionally sized core? The giant impact hypothesis, the leading theory that a Mars-sized object called Theia collided with early Earth, struggles to explain where all the impacting body's metal went. Computer models show such an impact should have left the Moon with at least 30% metallic core material. Yet lunar samples contain barely traces of iron-nickel alloys, and the seismic shadows confirm their scarcity extends deep underground. Alternative explanations only deepen the mystery. One radical proposal suggests the Moon's core wasn't lost, it was never there to begin with. A handful of scientists speculate that what we call the Moon might actually be the remnant of an ancient megastructure, its interior deliberately engineered to specific density parameters. Others point to exotic physics, proposing that intense gravitational forces during formation could have squeezed out metallic elements like juice from an orange, leaving behind a rind of silicate minerals. The implications reverberate beyond planetary science. Without a substantial core, the Moon shouldn't have enough internal heat to drive geological processes, yet we've seen evidence of possible recent volcanic activity. Its weak gravity shouldn't retain an exosphere, yet gases mysteriously pool and dissipate across its surface. Every anomaly we've explored, the shallow craters, the hollow echoes, the magnetic ghosts, finds its roots in this central enigma. The Moon doesn't just lack a core, it lacks the very thing that makes a world, and that realization forces us to confront an unsettling possibility. Maybe we've been wrong about what the Moon truly is from the very beginning. Footage from the Apollo missions shows something impossible: dust creeping across the Moon's surface in broad daylight without a whisper of wind. In one eerie sequence, a pale haze of particles drifts uphill, defying gravity as it swirls in slow, deliberate ribbons. Elsewhere, astronauts' bootprints vanish within hours, erased by some unseen force. This isn't just drifting sediment, it's dust moving with purpose, as if pulled by invisible strings. And the most unsettling part, we still don't know what's causing it. The Moon's dust or regolith isn't like Earth's dirt. Under a microscope, it looks like shattered glass, jagged and electrostatically charged from eons of solar radiation bombardment. Scientists long assumed this static cling explained the movement, with particles repelling each other like magnets. But watch the slow-motion replays and the theory unravels. Apollo 16's cameras captured dust cascading down slopes at a steady 5 miles per hour, forming coherent streams that behaved more like liquid than individual grains. Charged particles don't flow together, they'd scatter chaotically, yet this dust moved in synchronized waves, cresting over rocks like a silent tide. Then there's the direction problem. Electrostatic forces should push particles away from the sun's intense light, yet time lapses from NAS, a lunar reconnaissance orbiter, showed dust migrating toward sunlit areas. At the crater edges of the Sea of Tranquility, plumes of material hover centimeters above the surface for minutes at a time, undulating as if suspended by an energy field. Side-by-side comparisons with lab experiments reveal the disconnect. Earthbound simulations with charged dust create weak, disorganized movement, nothing like the coordinated flows seen on the moon. High-speed footage adds another layer of mystery. When the Apollo lunar module ascent stages launched, their exhaust should have kicked up dust in predictable, cone-shaped plumes. Instead, the particles shot outward in flat, disc-like sheets, hugging an invisible plane before abruptly dispersing. Engineers expected turbulence. What they got was geometric precision. Later, the Surveyor 3 probe recorded dust accumulating on its solar panels in perfect concentric rings, a pattern that mirrors crop circles more than random static buildup. Theories abound, from hidden magnetic anomalies to quantum levitation effects. Some researchers propose the dust is caught in fluidic electrostatic vortices, miniature tornadoes of energy generated by the moon's interaction with Earth's magnetosphere. Others point to the lunar horizon glow, a phenomenon where astronauts reported seeing luminous bands hovering above the surface at sunrise. Could these be clouds of levitating dust held aloft by forces we've yet to quantify? Perhaps the most radical suggestion comes from a declassified 1971 Bell Lab study, which noted that certain dust movements mirrored the behavior of ferrofluids, liquids laced with metal particles that form spikes and swirls when exposed to magnetic fields. The report speculated that the moon's dust might contain undiscovered metallic compounds, turning entire landscapes into responsive, shape-shifting canvases under the right conditions. Every robotic lander sent since Apollo has seen these movements, yet none have fully explained them. China's Chang missions documented fresh tracks appearing overnight near their rovers, as if the ground itself were alive. Until we understand why lunar dust doesn't obey the laws of physics as we know them, one truth remains: the moon isn't just a static rock. It breathes through its dust, whispering secrets in a language we're only beginning to decipher. Here's something you've probably never questioned: why does the moon always show us the same face? It might seem like a simple fact of nature, but the reality is far stranger than you think. Tidal locking, the phenomenon that keeps one side of the moon perpetually turned toward Earth, isn't unique. Many moons in our solar system are tidally locked to their parent planets. But here's the catch: they're almost never perfectly synchronized. There's usually a slight wobble, a tiny oscillation called libration that lets observers glimpse around the edges over time. Not so with our moon. Its synchronization is so precise, so unnervingly exact, that we've only ever seen about 59% of its surface from Earth. That's not just rare, it's statistically bizarre. Let's break down the numbers. Even when a moon becomes tidally locked, imperfections in its mass distribution or orbital eccentricity should introduce slight rocking motions. Take Mars' moon Phobos. It's locked, but its irregular shape causes noticeable oscillations. Jupiter's moons, same story. Yet our moon's rotation matches its orbit with clockwork precision, as if some hidden counterweight inside it perfectly balances any wobble before it can happen. Statistically speaking, the odds of such flawless synchronization occurring naturally are astronomically low. Some calculations suggest less than 1 in a million. Animations of alternative rotations drive home just how unusual this is. If the moon had even a subtle libration like other moons, we'd witness its far side gradually peeking into view over decades. Instead, what we get is a celestial freeze frame, one face eternally staring back at us like a locked door. Some researchers argue Earth's gravity sculpted this perfection over eons, smoothing out irregularities until the rotation stabilized. But that explanation doesn't hold up under scrutiny. Simulations show that without an unnaturally uniform mass distribution inside the moon, such perfect locking shouldn't be possible. Here's where things get even weirder. The moon's mass isn't evenly distributed at all. Its far side has a thicker crust, and gravitational maps reveal enormous, lopsided concentrations of dense material beneath basins like Mare Imbrium. These asymmetries should disrupt synchronization, yet the moon defies physics by staying perfectly aligned. Some theorists speculate that these anomalies might actually be counterbalancing each other with impossible precision, like a cosmic gyroscope designed to maintain equilibrium. The most chilling possibility, this might not be a coincidence at all. Early NASA reports briefly entertained the idea that the moon's rotation could be corrected by internal mechanisms, structures, or dense masses deliberately arranged to stabilize its face toward Earth. Wild as it sounds, it's hard to ignore the math. In a universe governed by chaos and imperfection, our moon's perfect sync stands out like a fingerprint on glass, something shaped, not random. Whether by natural fluke or something more profound, one thing's clear: the moon isn't just watching us, it's making sure we never see it blink. Scientists studying moon rocks face a paradox that shakes the very foundation of lunar science. Meteorites blasted off the moon and found on Earth tell a different chemical story than the pristine samples brought back by Apollo astronauts. Side by side in laboratory trays, these cosmic fragments look identical: gray, pitted, and ancient. But under electron microscopes and mass spectrometers, their secrets spill out. The meteorites contain minerals never seen in Apollo samples, ratios of isotopes that shouldn't vary, and traces of elements that simply don't match. This isn't just scientific noise, it's a fundamental discrepancy that forces us to question whether we truly understand the moon's composition, or if we're missing something far more profound. Take oxygen isotopes, the fingerprints of a celestial body's origins. Apollo samples show a near-perfect match with Earth's isotopic signature, supporting the giant impact theory. Yet lunar meteorites found in Antarctica and the Sahara display subtle but statistically significant shifts in these same isotopes. Some contain up to 12% more potassium and phosphorus than any rock Neil Armstrong scooped from the Sea of Tranquility. High-definition spectral comparisons reveal even stranger gaps. Meteorites harbor minute crystals of moissanite, a silicon carbide mineral that forms under extreme temperatures unseen in lunar geology. If these rocks all came from the same moon, why do their birth certificates tell conflicting stories? Mainstream explanations fall into two camps. Contamination theorists argue Earth's atmosphere alters meteorites during their fiery descent, or that Antarctic ice leaches strange minerals into them over millennia. But this doesn't hold up to scrutiny. Lab simulations show oxygen isotopes remain unaffected by atmospheric entry heating, and sealed Antarctic meteorites stored in nitrogen chambers still exhibit the anomalies. The other camp proposes multiple lunar terrains that Apollo astronauts sampled only a thin slice of the moon's crust, while meteorites represent deeper layers or distant regions. Yet orbital surveys should have detected such dramatic geochemical provinces, and they haven't. Footage from NASA, a lunar sample lab, highlights the enigma. In one sequence, a researcher places an Apollo basalt and a lunar meteorite under identical laser ablation spectrometers. The Apollo sample's readout shows predictable spikes for aluminum and calcium, classic markers of lunar highlands. The meteorite's screen flashes unexpectedly high lanthanum and cerium, elements typically associated with volcanic hotspots. Frame by frame, the graphs diverge like estranged siblings. Even more telling are the age discrepancies. While Apollo rocks cluster around 3.9 billion years, evidence of the late heavy bombardment, meteorites frequently date a billion years younger, suggesting volcanic activity long after the moon's supposed geological death. Alternative theories range from the provocative to the radical. Some planetary scientists speculate meteorites could be fragments of Theia, the hypothesized planet that collided with Earth to form the Moon, preserved in lunar soil and later ejected. Others point to the two moons theory, that Earth once had a smaller companion moon that merged with ours in a slow-motion collision, leaving pockets of alien chemistry. Then there's the unsettling possibility raised by a 2015 Caltech study that what we call lunar meteorites might include imposters' rocks from a stealth planetesimal that once shared Earth's orbit, its remains peppering our world with cosmic false flags. Every new lunar meteorite discovery deepens the mystery. A 2022 find in Mauritania contained bubbly veins of glass with nitrogen signatures matching no known lunar sample. Another, recovered from Australia's Nullarbor Plain, held nanodiamonds arranged in fractal patterns that microscopes reveal as miniature engineering marvels, structures nature shouldn't assemble by chance. Whether these inconsistencies stem from our limited sampling, hidden lunar processes, or something more extraordinary, one truth emerges: the moon we see from our backyard isn't the only moon that exists. There's another version written in these wandering stones, and its story has just begun to be told. The Apollo 17 mission left more than footprints in the lunar dust. It left behind a mystery buried in the data from its gravimeter. When astronauts deployed the lunar surface gravimeter, scientists expected it to measure subtle shifts in the moon's gravity. Instead, it recorded something far stranger: waves rippling through the lunar interior at speeds that defied every known law of physics. These weren't ordinary seismic waves. On Earth, vibrations from quakes travel through the crust at predictable speeds around 5 to 8 kilometers per second through solid rock, slowing in loose sediment. But the Apollo data showed waves moving through the moon at a staggering 100 kilometers per second. To put that in perspective, that's faster than some spacecraft travel in Earth's orbit. Visualizing the data reveals these waves pulsing through the moon like sonar pings through water, an impossibility given the moon's dry, rigid composition. The experiment's original purpose was straightforward. By measuring how the moon's gravity fluctuated, researchers hoped to detect gravitational waves from deep space ripples in spacetime itself. Yet the instrument picked up something far more unsettling. The wave patterns followed rhythmic intervals, their peaks and troughs aligning in near-perfect harmonics, as if resonating through some hidden lattice beneath the surface. When engineers recreated the signals as audio, the result was eerie, a low, oscillating hum with a metallic timbre, resembling a giant tuning fork struck in a vacuum. Compare this to known materials: granite, basalt, even ultra-dense metals like osmium. None propagate waves at these velocities. The closest match: hypothetical metamaterials, engineered structures with atomic arrangements designed to manipulate energy in ways nature doesn't replicate. Some physicists privately speculated the readings suggested a crystalline substructure beneath the moon's crust, something with properties beyond conventional geology. Others pointed to the Apollo 12 seismic data, where moonquakes echoed for hours, another anomaly hinting at a hollow or honeycombed interior. Gravitational wave specialists were equally baffled. If these signals weren't seismic, what generated them? The waves didn't match meteor impacts or tidal stresses. Declassified memos reveal NASA briefly considered whether the gravimeter had malfunctioned until cross-referencing with passive seismometers confirmed the phenomenon. The waves were real, they were fast, and they were utterly inexplicable. Decades later, modern simulations only deepen the puzzle. Supercomputers modeling lunar composition struggle to replicate the data unless they introduce theoretical materials with zero analogs in nature. Some models require a network of ultra-dense, superconductive veins threading the moon's mantle, a scenario that sounds more like science fiction than planetary science. Whether the answer lies in undiscovered physics, remnants of alien engineering, or something else entirely, the Apollo 17 gravimeter stands as one of the moon's most haunting enigmas. Those waves didn't just travel through rock, they pierced the heart of our assumptions, leaving behind a question that still reverberates through the halls of science. What exactly did the moon whisper back to us in 1972, and why haven't we been able to decipher it since? From hollow moonquakes that ring like bells to fleeting clouds defying the vacuum of space, each mystery we've uncovered peels back another layer of the moon's enigma. Think about it. Our closest celestial neighbor, a world we've walked on, still hides towers that vanish, dust that moves without wind, and gravitational whirlpools that tug satellites off course. Even the rocks tell conflicting stories, as if the moon itself can't decide where it came from or what it's made of. And let's not forget those eerie lights, flares, and pulses in places no human technology could reach, dancing across the surface like coded signals we've yet to decipher. The greatest revelation isn't any single anomaly, it's the collective weight of them all. The moon shouldn't have liquid water, yet it lingers in sun-scorched soil. It shouldn't have a magnetic field, yet localized forces scramble instruments like invisible hands. It shouldn't have an atmosphere, yet gases pool and vanish with the precision of a breathing organism. Every time science insists the moon is dead and ordinary, it responds with another paradox, another wink from the cosmos reminding us how much we still don't know. So here's the truth: the moon isn't just a rock. It's a riddle wrapped in dust, a puzzle box orbiting Earth, daring us to look closer. Whether you're haunted by the Apollo transmissions that went silent, the impossible geometries of the shard and the cube, or the chilling precision of its tidal lock, one thing's certain. The more we learn, the less we understand. Now it's your turn. Which mystery shook you the most? Was it the bell-like echoes hinting at caverns beneath the surface, the swirling magnetic ghosts painting the landscape, or something else entirely? Drop your thoughts in the comments, because the conversation about our moon is far from over. As the camera pulls away, revealing the dark side shrouded in shadow, remember, the greatest secrets aren't always hidden. Sometimes they're right above us, glowing in the night, waiting.